So, hello everyone. Today we will be solving third weekly contest. There were four questions in it, and let's directly go to the contest page. Okay, let's solve the first question. Is subsequence? It is a pretty easy question. We just okay. There were two strings S and T. We just have to return that whether S is a subsequence of T or not. Okay, we everyone know that what is subsequence. A subsequence is a string that can be formed from original string by deleting some of the characters without disturbing relative position. So here if we just remove H, G, D, so ABC will be remaining, and which is a subsequence from T, and we have to return true for it. X is a character in S in the second example, and which is not occurring in T, so we just return false. Okay, this is a simple two pointer problem. We just have to initialize two pointers, let's say int I and j, and I will be traversing through a string and j for T. So let's I less than s dot size, and then j should be empty dot size. Okay, so whenever we encounter the same value, we just move the I pointer forward, and if I pointer reaches to the end and every character occurs in the T in sequence, so we say that S is a subsequence, or else we just return false. So if S of I is same as P of J, so we move the S pointer forward, and in every other case we move the J pointer forward, and at the end if we have I double equals to S dot size, which means our all the values is occurrence has an occurrence in T, so we say it is a valid subsequence. Let's run it. Yes, it's running fine. Submitting the code. Okay, let's solve another question. UTF-8 validation. Here we are given an integer array data. We just have to return that it is valid UTF-8 encoding or not. It's the interesting question. Character UTF-8 can be of 4 bytes long. Okay. For every byte, 1 byte character, the first bit should be 0. And for n byte character, first n bits have to be start with 1, and the n plus 1th bit should be 0. Rest of the n minus 1 bits with the most significant. Okay, got it. So if number of bytes is 1, it should start with 0. If it is 2, 3, 4, then 110, and rest of the elements should be anything. And the bit next byte should have 10 at the start. So if n equals to 2, we have one element which has 10 at the start. If n equals to 3, it has starting with 1110, and next two elements have start 10. Okay, so we just need to keep track that how many elements should be used to store 10. So okay, we just need to see that which of the following is the count variable for this system, and if any of this violates, we have to return false. Okay, and we have to only worry about least significant 8 bits. That's pretty good. Okay, here we have given data 197, 130, and 1. So none of the characters is above 8 bits representation, so we have to consider all bits. Okay, this is the binary of it. And for 197 there is 1110. So by looking at it we can say that it should have one character starting with 1. Okay, so here it is 10, and rest of the element can be anything, and the last bit is also starting with 0, which is also valid. So first is 2 and another one is 1. So yes, it is valid UTF. Here 235, 140 and 4, it has 3, 1 and 0. So this case, so we require next two bits starting with 10. So it is starting with 10, but it isn't, so we just returns false. Okay, got it. Constraints are pretty good. Of and log n is fine. Okay, let's keep a count variable which stores that how many number of bytes are required. Okay, and we traverse through the data array auto iterator on data. Okay, if our count is equals to 0, else case we handle accordingly. So we see that if there are 1, 2, 3, 4, 5, okay, if we right shift our iterator by 5 units and it is equals to in binary 1110. Okay, so we can say that our count variable, so one value is required, so okay, count equals to 1. Similarly, okay, here what it is doing, we require one variable having 10 at the start, so we assign count to be equal to that. Okay, similarly if it is left shifted by 4 units and it is equals to 1110, so this case, so we require two variables. Okay, so count equals to 2, else if we shift it by 3 units, if it is equals to 4 times 1 and 0, so count would be assigned 3 value. And also let's handle this case, else if it is shifted by 7 units and it is non-zero, let's say it is 1, so we just return false because there is no case like this. And if count is non-zero, that is if we have assigned 1 to it, so we just need to check for it that it is valid or not. So we just say that if we shift it by 6 units, because there are 6 unknown values, and if it is equals to 10, then it's good. If it is not equals to it, so we just return it false. And if it is valid, then just we can minus it, so it will be removed out and count value will be reassigned to 0. And for the if there are more than 3 values, then it will check for another values as well. At the end, if count is equals to 0, then we return true or else false. Let's run the code. Yes, it is running fine. Let's submit it. Okay, let's see the another question. Decode string. We are given an encoding string, return its decoded string. Okay, the encoding rule is this square bracket. You may assume that the input string is always valid. Okay, no extra white space, square bracket. Okay, fine. Test case should never over exceed 10 to 5. Okay, if we have 3A and 2BC, so it will return triple A and BC. Okay, if it is concatenated, then there will be two C's. Okay, and it will concatenate with A's. So A double C, and it should return 3 times A double C as its output. Okay, got it. So yes, the most first thing that comes to my mind is use a stack data structure and store the top element to be how many times it should come, and just combine all of the values. Let's say 2BC, so BC, and the last element at the stack is triple A. We concatenate it and just return it as our output. Okay, so let's try to implement it as well. Let's take stack data structure, and we just traverse to the string. I list n I plus plus. Let's assign name equals to size of s. Okay, we would we would be looking for this character. If s of I equals to this, then do something or else do something. If it is not equal to this, then we can just simply put the value in the stack. Okay, and we are storing string, so we have to typecast the character into it, s of I. Okay, and if it is equal to this character, that is closing bracket, we find that what is the element inside it. So if a is there, then string store it. String temp equals to this. Okay, if BC is inside it, so we have to find that what is it. So how can we find is, while we doesn't find this character, till then we will move. If stack dot top is not equals to this character, we would do temp equals to stack dot top plus temp and stack dot pop. We would remove first get C and store it in temp. After that, B would be concatenate with it and BC would be stored in temp. And when we reach this, we just come out of the while loop and we remove that character as well. That is, we are removing the opening bracket. And after that, we have to see that how many times you have to repeat it. So let's store it as well. String num, let's call it numm equals to this, while we are getting digits, while is digit. So as of we have to see what are the number. It can be greater than 2 and 12, so we have more values as well. So we can take a longer example. If it was 13, it would be difficult to store it. Okay, So we would do jab tak empty if stack dot empty end each digit of stack dot top, and we are storing it in the form of string, so first character should be there. Okay, and we just added num equals to stack dot top plus num stack dot. Okay, let's see out once and find this being correct or not. Let's return any number one every time. Return the string as it is. Okay, rerun the code. 3 and 2. So 3 times and 2 times. Okay, what is 2 and 3? Okay, 3, 2, 13. Fine. Okay, let's convert it into integer as well. Int num equals to string to integer. String to integer of num. Okay, now let's store the final value into it. So how many time it is repeating? So we have found 2 and we have to find BC as well. So we concatenate BC for 2 number of times. So while num is 0. Okay, and what we will do is return equals to where we have stored it, temp plus return, and then we push the value it into stack. Okay, I think should be fine. Now final answer should be stored. Let's call it string answer equal to this until and unless stack is empty. We would do answer equals to answer plus stack dot top plus answer stack dot top every time return answer. Let's run the code. Yes, it is running fine. Let's submit it. I guess you get the logic. What we are doing here is, okay, let me explain this portion. I think it should be complicated for some of you. We have to store the value 13. So we just store it into a string data structure and then reconvert the number into integer here. Okay, we are checking that it is digit or not, and it should be fine. Let's solve the last question. Last question is longest substring with at least k repeating characters. Okay, we are given a string and an integer k. We have to return the longest substring of s such that frequency of each character in the substring is greater than or equal to k. If no substring exists, return 0. Okay. If triple A double B is given and k equals to 3, then only one substring is possible, triple A. Okay. And if AB, ABBC k equals to 2. So 1, 2, 1, 2, 3. Yes. Answer should be 5. Yes, correct. We can solve it using divide and conquer method, I guess. So, okay, what we will be looking for is first character which is not valid, and let's say while we are traversing here, whenever we find C, its frequency is not greater than 2, right? So we just omit it and we solve it for the remaining substring. Let's take a longer example. It would be better. A B B C D D E F G G E H. So if we take this and k equals to 2, let's say, so once we find C, we know that if C would be in the substring, our whole substring couldn't be our answer. So our search space would be reduced to this and this. So we can solve it for this portion and this portion separately. Here also, once we find H, we remove it and solve it for this portion. So this is our divide and conquer strategy. So it's a recursive approach. Let's write the code. Int n equals to s dot size, and we call a function called solve. Our starting index would be 0, ending would be n, and let's pass the string and k. Okay, and solve first character. Let's call it start, last is end, and string s and end k. Okay, once our end reaches k, and we just return 0. Okay. What we will be looking for is a character which is not okay. So we would be looking for a non-repeating character. So we need to store every character into map hash. Okay, hash array 26, assign it to 0. Traverse to the string and hash of s of I minus a plus plus. Okay, not 0 to end, start to end. Okay, now we would be looking for C. So a midpoint need to be found where we can split our search space. So mid equals to start to end, mid plus plus. If our if the character is a, so we don't need to consider it. So if s of mid is greater than equals to k, so we don't need to worry about it. Else case, if it is this, so what we have to do is we have to call for this and this search space. So we return solve of start till mid. Okay, okay, we have to only we have to find longest substring, so maximum of this and this. Start mid plus 1 s and k. Okay, mid plus 1 k and mid new equals to this. Also we can optimize it a little further. After C, let's have an example with D, E, G, G, H. So if there is a character, then why we need to search it for this also? Why we need to keep on increasing our recursion? So we can omit D here only. So how we can do it is while one new mid and EW is less than and also if our hash value is lesser, that is this is less than k, then we update the mid. So it will skip every unnecessary values and it will be more optimal. Let's try to run the code. Okay, there is an error. Solve. Okay, using bracket is required. Okay, we have to return the value as well here. What we should return is end minus start is our length of the substring. Let's run the code. Oh, what's the error? Okay, let's see. 0 and S and K. Okay, and once we overcome it, then we just return 0. Hash data structure is created. This. Okay. Oh shit, what have I done? S of mid minus A. So I need to S of mid minus A should be greater than equal to K. Yes. And rest of the thing I think it should be fine. Run it. Okay, it's still it is giving 0. It's not create properties. Oh shit. It should be hash of this. We should be searching in hash, not this. And intermediate equal to mid plus 1. Hash of size 26. Yeah, error here. What is the error? Stack overflow. Okay, let's reconsider it. Okay, we are assigning 26. Okay, correct, correct. Start to end. We are traversing. Okay. Oh shit. I'm so mad. Another search space would be from mid plus 1 till end, right? I think you understand. Yes. How silly. Let's submit it. Should be running fine. Yes. Thank you.